Welcome to your severe weather analysis for AEST Rock on Sunday, November 23rd, 2025. This is your morning sounding from 10 a.m. local time, and we are analyzing conditions across the Red Center. If you find this analysis helpful, please like and subscribe to support continued severe weather analysis. Looking at our morning skew-t diagram, we are seeing a classic dry outback profile. The red temperature line shows surface temperatures already at 33.5 degrees Celsius, while the green dew point line sits well to the left at just 11 degrees, giving us a huge temperature dew point spread of 22 degrees. This dry air means the mixed layer CAPE is essentially zero, as shown by the lack of any pink shaded area between the parcel path and the environment. Notice the blue dashed mixed layer parcel path stays to the left of the red temperature line throughout the lower atmosphere, meaning rising air simply cannot become buoyant. The atmosphere is stable this morning with wind shear around 6 meters per second through the lowest 6 kilometers. Now here's where things get interesting. With a forecast maximum of 41 degrees, we see a dramatic transformation in our heated afternoon skew-t. The orange heated parcel path now shows the surface parcel reaching its level of free convection and generating around 900 joules per kilogram of surface-based CAPE, shown by that pink shaded area extending up to around 280 hectopascals. However, notice the blue shaded area below showing some remaining inhibition that needs to be overcome. The lifting condensation level sits extremely high at 3,600 meters above ground, which is typical for this arid environment. The steep lapse rate of 7.6 degrees per kilometer between 850 and 500 hectopascals supports strong updrafts if convection can initiate, but the very high cloud bases and dry air make severe weather unlikely. Any storms that do develop would produce mainly wind given the high downdraft CAPE of over 1,500 joules per kilogram. Looking ahead to tomorrow morning, the machine learning model shows zero CAPE values persisting with deep layer shear increasing to around 17 meters per second. The lifting condensation level remains extremely high at over 3,000 meters. While the shear is supportive of organized storms, without any instability the atmosphere simply cannot support thunderstorm development. By tomorrow afternoon, the models continue to show subconvective conditions with zero CAPE and moderate shear around 11 meters per second. The lifting condensation level climbs even higher to over 4,000 meters. This suggests Monday will also see a stable atmosphere across the region with no thunderstorm activity expected. Our multi-model evolution chart tells an interesting story. The forecast net model, shown in teal, is quite bullish on instability, suggesting CAPE values could spike to over 14,000 joules per kilogram by this afternoon. However, GraphCast and Pangu shown in red and blue disagree sharply, keeping values near zero. This massive model disagreement highlights the challenge of forecasting convection in arid environments. Looking at deep layer shear in the bottom left panel, all models agree on a substantial increase tomorrow morning to 15 to 20 meters per second before relaxing. The cloud base evolution panel on the bottom right shows consistently high lifting condensation levels between 3 and 4,000 meters throughout the forecast period. The hodograph reveals a relatively compact wind profile concentrated in the lower right quadrant. Winds are generally easterly to southeasterly through the lowest 6 kilometers with modest speed shear of just 6 meters per second. The storm relative helicity values are 48 meters squared per second squared in the lowest kilometer and 105 through 3 kilometers. These values are respectable, but combined with the marginal instability, supercell potential is extremely low. The bunker's right mover storm motion marker shows any organized cells would track toward the northwest. The atmospheric refractivity profile shows some interesting features for radio propagation. We can see two elevated duct layers marked by the orange bands, one near 1,000 meters and another around 5,800 meters. These features indicate temperature inversions that can trap radio waves and cause anomalous propagation. Between these layers, the refractivity decreases smoothly with height, indicating generally normal propagation conditions through the middle atmosphere. In summary, while intense heating will generate some surface-based instability this afternoon, the extremely dry air mass and high cloud bases make significant thunderstorm activity unlikely around AEST Rock today and tomorrow. Any isolated convection would be elevation-driven and produce mainly gusty winds from evaporatively cooled downdrafts. Always consult Bureau of Meteorology official forecasts and warnings. This analysis is provided by Distant Curve Remote Area Telecommunications. If you found this helpful, please like and subscribe to support continued severe weather coverage for remote Australia.